Hi, we're going to talk about similar triangles and problems that you can solve using similar triangles. First of all, triangles will be similar if all three ratios of the corresponding sides are equal. I forgot to write equal. So how does this work here? Well, you have these two triangles and we want to show that they are similar. So we're going to start taking ratios. We're going to do 9/3. These are similar, corresponding sides. And then we're going to take another ratio of 15/5. And then another ratio of 12/4. We're going to put equal signs here with question marks because we don't know for sure. 9 divided by 3 gives you 3. 15 divided by 5 gives you 3. 12 divided by 4 gives you 3. All three ratios are equal. These two triangles are going to be similar. Okay? You could have done the ratios the other way around, like 3/9 and 5/15 and 4/12. You still would have gotten the same exact values for all of them. Alright, so let's take a look at problems. So we have these two triangles. It tells us that they're similar. This symbol here represents similar. So ABC is similar to DEF. This side, if you can see, this is 8, this is 6, this is 24, and we need to find the length of EF. So EF, let's call this X. And the way we solve them is by setting up proportions and solving them. So I can do 8/24, these two are corresponding sides, is going to equal to 6/X. There are several ways how you can set up proportions here, but it's all going to come down to setting them up in a similar way. So we go from this side to that side, and then from this side to that side. When we solve proportions, we cross multiply. So we're going to have 8 times x equals 6 times 24, and 6 times 24, let me write 6 times 24, which gives us 8x equals 504. No, it's not 504. This is going to be 144. So 8x is 144. Divide both sides by 8. And we're going to get 18. And that's it. Right, this next problem, triangle ABC is similar to triangle DEC. So ABC, triangle DEC. We're trying to find the lengths of BC and CE. So let's call BC X, just to make it easy, and CE, let's call this Y. It's just going to make it easier to set it up. When you do problems with similar triangles, you need to have two corresponding sides whose lengths are going to be known. So we have 6 here and 7.2. So we're going to use that. 6/7.2 is going to equal. So to find X, the side that corresponds to BC is side CD. So it's going to be, since we started from here, then we're going to have X on top divided by 10.8. Okay, again, this side over that side is going to equal this side over this side. Cross multiply, 6 times 10.8 is going to be 64.8, and it's going to equal, and 7.2 times x, 7.2x, divide both sides by 7.2, and we're going to have that x equals 9. So x is 9. I can write this here. And then to find y, we set up another proportion. We're going to use 6/7.2 equals, so 6/7.2, we're trying to find y. The side that corresponds to y is AC. It is going to be 8/y. Cross multiply, 6y equals 8 times 7.2 is going to equal 57.6. And then we divide both sides by 6. So y is going to equal 9.6, and these are the answers. Okay, moving on. Another problem, two triangles that are similar. ABC is similar to DEF. Find the lengths of AC and DE. So AC is right here. Let's call this X. DE is right here. Let's call this Y. we need a pair of two sides that are corresponding, and we know their lengths, so this one and this one. So BC and EF. We're going to write that 18 over 12 is going to equal, so 18 over 12 is going to equal x over 4. Cross multiply. 18 times 4 is 72 equals 12x. Right, and then divide both sides by 12, and we're going to get x equals 6. So we're done with that. To find y, let's set up this again, 18 over 12. So 18 over 12, that's going to be 9 over y. Cross multiply, 18y equals 12 times 9 is 108. Divide both sides by 18, y equals 108 divided by 18 is going to be 6. This triangle ABC, the smaller one, is similar to triangle ADE, the larger one, and we need to find x. So here's what we're going to do. When we set these up, let's start with a smaller triangle. So this side measures 7 divided by the long side, the whole thing is going to be 7 plus 5, which is going to be 12. So 7 over 12, again 7, which is the small one, over 12, which is 5 plus 7, is going to equal 7 over x. And in this case, when you cross multiply that, that's 7x equals 84, and x is going to equal 12. So this side here is actually 12. Okay, moving on. Next problem, so we have two triangles that are similar, but we're going to set it up the same way. So 12 over x is going to equal 12 plus 6, which is 18, over 32. So 12 over x is 18 over 32. This whole thing is 18. We cross multiply. 12 times 32 is 384 equals 18x. Divide both sides by 18 to get x by itself. And x is going to be, well, it doesn't divide. So it's 384 divided by 18. So what can we do? We can divide 384 by, we can divide 384 by 3, I think. 384 can be divided by 3. Yeah, that's 128. And we divide 18 by 3, it's going to give us 6. Right? So we can simplify it a little bit more. 128, but they both divide by 2, so 128 divided by 2 is 64 divided by 3. So 64 divided by 3 is going to be the answer, and that's what we have. This triangle here, BAY is similar to VHY, and we need to find x. So we have this side, which is 16. Now, yeah, we can use this side, so 16 over the long side, which is going to be 16 plus 22, that's 38, equals 17, which is the short one, divided by the whole thing, which is x, and that's what we're looking for. So 16x equals 17 divided by 38. I'm sorry, 17 times 38. That is 646. It's not going to divide, so x equals 646 divided by 16. 646 can only be divided by 2, which is going to be 323 over 8. Okay, so in the real world we have a lot of applications for this concept that allow you to do something that's called indirect measurement. Indirect measurement is when you cannot measure things directly. So in other words, if you want to measure the height of that tree, you don't have a way of getting on top of the tree and dropping down a line to figure out how tall that is. So what do we have here? We have a 4-foot wall that casts a shadow that's going to be 6 foot long. At the same time, the tree casts a shadow of 24 feet. And the question is, how tall is the tree? So what we do here is we're going to set up a proportion. This is h. So we're going to say h over 4 is going to equal 24 over 6. We cross multiply, so 6h equals 4 times 24 is 96, and h is going to be 96 divided by 6, which is going to be 16, so the tree is 16 feet tall. By the way, this can help you make some pretty accurate measurements if everything that you measure there is accurate. Alright, we have another situation. This is how actually height of tall objects can be measured. So a boy who's 5 foot tall places a small mirror so that in this mirror he sees the reflection of the tip of the flagpole. The mirror is 8 foot away from the boy and 24 foot away from the flagpole. We need to find the height of the flagpole. These two triangles here are actually going to be similar. And we're going to set up our proportion there. 5 over h. So the height of the boy over the height of the flagpole is this distance. So 8 over this distance, 24. Cross multiply, we're going to get 120 equals 8h. And h is going to be, if you divide 120 by 8, that's going to give us 15. So the flagpole is 15 feet tall. All right. And our last example here is from point A, you can catch the tip of the 2-meter stick and the top of a tree that are in the same line of sight. We know that this distance is 3, this whole distance is 30, and the stick is 2 meters long, and we want to know how tall the tree is. So let's call this h. And let's set up our proportion. So h over 2 is going to equal, so h is the whole thing here. That's going to be this whole thing here, which is 30 over 3. 3h equals 60, h equals 20. So the tree is 20 meters tall. Okay, and this is how it's done.